Hello everybody. We are going to do some problems from section 7.2 from the 5th edition of the Practice of Statistics. Today we're specifically going to focus on number 29, 35, 37, 43, and 45. Let's start with 29. Suppose a large candy machine has 45% orange candies. Imagine taking a simple random sample of 25 candies from the machine and observing the sample proportion p hat of orange candies. All right, then they start to ask me about a mean and standard deviation and things. So before I get too far, I really like to kind of highlight the numbers that are in the problem and think about what notation, what variables go with them. 45% is supposedly the percentage that is inside the whole entire machine, so that is going to be a p, lowercase p, which is the parameter. Our sample size is 25, so that should be a lowercase n. And then they mention we're going to want to answer some things about p hat. The very first question says, what's the mean of the sampling distribution of p hat? Well, we should know from looking at our formula sheet that that is just going to be equal to p. So there's not really a whole lot to do with that one. And there's not any conditions to check. But if we want to use the formula for standard deviation, this goes back to the fact that this kind of imitates a binomial distribution. So we kind of need to check bins. And the I part of bins is independence. So essentially, we need to make sure that this is independent before we are allowed to use the formula for standard deviation. So that's why they say check to make sure the 10% condition is met. Which was nice of them to tell us that. Often on the AP test, you will not be told. It'll just say at the top of the question, be sure to check all conditions necessary. So you need to know that the 10% condition is necessary for finding the standard deviation of a sampling distribution. 10% condition tells us that the sample size is less than 10% of the population. So with notation, it looks like this. Now, we don't actually have the population size, but they did tell us that this was a large candy machine. So our sample size is 25. We can assume, what I'm going to write here is, this is less than 10% of all candy in the machine. And I might make a note that I think would probably be helpful to make, that we're going to assume that there's more than 250 candies in the machine since it's large. Okay, so that's kind of a classic, like, just if you don't have the actual population size to put in there, just say all the candy in the machine. So since this is met, that means I'm allowed to use the formula for standard deviation, which again, this is on your formula sheet. I would encourage you not to memorize this. That's just going to take up your brain space. So if I just write down this formula from the formula sheet, this is 0.45 times 0.55 over 25. We get 0.0995. So that is the standard deviation. And that is a proportion, so it doesn't have units. Question C says, is the sampling distribution approximately normal? So again, they were really kind to us and told us what to check. But on the AP test, they're not going to do that. And on our test, I'm not going to do that. So you need to know, if you are trying to see if this is normal or not, that you need to check the law of large counts. Just as a reminder, this is the law of large counts right here. So I'm going to plug those numbers in. 0.45 times 25, 0.45 times, 0.5, back up. I'm just going to write it in the right order so I'm not being confusing. N is 25. So we have 25 times 0.45, and then we have 25 times 0.55. I can actually do that out and see that this is 11.25, which is greater than 10, so that checks out, which means this one's going to be even bigger. It's 13.75. That's greater than 10, so that checks out. So I am allowed to say that the sampling distribution is approximately normal. Okay, so because the law of large counts is met, the sampling distribution is approximately normal. The last thing says if the sample size was 100 instead of 25, how would this change the sampling distribution of p hat? Well, let's think about this. Let's just think about the questions that we just answered. We would, if we can assume that there's more than 1,000 candies in the thing, in the machine, then we can still essentially do everything that we just did. The mean of p hat is still going to be 0.5 because that's not dependent, 0.45, that's not dependent on sample size. But the standard deviation is. Do you notice how standard deviation is divided by n? So if we just think about this for a second, the bigger n is, because I'm dividing by it, the smaller the standard deviation is going to be. So let's just find the new standard deviation. Instead of dividing by n, I'm going to divide by 100. That is 0.0497. So that's something that changes. The standard deviation changes. And then also, if we just think about the law of large counts up here for a second, if I plug a number in bigger than 25, this is still going to be met. So that means it's still approximately normal. So it's going to be still approximately normal with the mean of 0.45. But the standard deviation decreases to 0.0497. So this is a really important point. The bigger these sample size is, the smaller the standard deviation is, which means we can be more accurate. Like the data is going to end up being less spread out, so we can actually be a little bit more accurate with things. Number 35, a U.S. Today poll asked a random sample of 1,012 U.S. adults what they do with the milk in their bowl after they've eaten the cereal. I drink it personally. Let p hat be the proportion of people in the sample who drink the cereal milk. So I would be in p hat. I would be one of those people. A spokesperson for the dairy industry claims that 70% of all U.S. adults drink the cereal milk. Suppose this claim is true. What is the sampling distribution of p hat, or what is the mean, and why? All right, so again, I kind of want to pull key numbers out here. Looks like we've got that one, and that one. That was a random sample, 1,012, so that's my N. Their claim is that 70% of all U.S. adults drink the milk, so that is a parameter. That's the proportion for the population, so like the true parameter. Honestly, this kind of like mirrors what we have already done in the last question a little bit. The mean of P of the sampling distribution is going to be P. As far as a reason why, it's because P hat is an unbiased estimator. And so that means that the mean of all of our samples should end up equaling the true value that we're looking for, the true parameter, which is P. Is the sampling distribution... first we have to find the standard deviation. So notice this actually like really is the same as number 29 as far as process. So I need to check the 10% condition because I cannot use the standard deviation formula until I have checked the 10% condition. Again, I don't know what all the adults are, like the number. But 10% of 10% of 10,000, 120 is what would equal this. And so we can assume that there's more than 10,000 adults in the U.S., so that's met. That means that we can do the standard deviation formula here. And I'm just plugging it straight into that formula. I end up getting 0.0144. And yeah, that's kind of all we have to do for that one. And then part C asks if the law of large counts is met, like basically to determine if this is normal. So I'm going to check this again. both have to be true. So, and they are. And you know what? Sometimes they're not. So you really do have to check. Okay, so I can like calculate both of those. This is 708.4, which is indeed greater than 10. This is going to be smaller since it was only 30%, but it was such a large sample size, it's okay. This is greater than 10. And so I can be like, therefore, this is approximately normal. All right. Of the poll respondents, 67% said that they drink the cereal milk. Find the probability of obtaining a sample of 10,012 adults in which 67% or fewer say that they drink the cereal milk if the milk industry spokesman claim is true. Does this poll give convincing evidence against the claim? Okay, so basically what we have here is a p-hat. Like we have done a sample, and our sample had 67%. The claim was that 70% of the adults drink it. So what we're trying to see is it possible for us to get a sample of 1,012 people that has a proportion of 67%? Like, is that possible or is it unlikely? It's not that far from 70%, but we need to do some calculations. The whole reason we wanted to figure out these mean and standard deviation is so we could apply it to the normal curve. And since this is normal, I can actually find what I need to find. So remember, whenever you do a normal curve, you put the mean and then the standard deviation here. And the question was, find the probability of obtaining a random sample with 67% or lower. So I'm going to shade to the left. And now I'm going to need to go to Staplet or use your calculator to find this percentage right here, which I got 0.0188. 0.0, actually that would be the z-score. The table would give you that answer. So if you could use the table, you could find the z-score and then use the table, or you can use the Staplet or your calculator and do it and get that. So really I should write this out, which is a little bit hard for me to write it out on the iPad neatly, but I should put this in words. This sketch with this label will give me credit for the work that I need, but I actually do need to answer the question in words. So let me start over again. We're going to say there is a 0.0186 probability of getting a sample. Sorry, I know this is hard to see or hard to read. In which 67% or fewer people, and you have to give some context. So it's like, what are these people doing? They're drinking the milk. Drink their cereal milk. So you know what? 67% doesn't seem like that far away from 70%, but our sample size is so big here that our standard deviation is pretty small, which means that 67% actually is kind of far away. That's only like a 1.9% probability of getting a sample that 67% has a p, like a proportion of 67% or less, which means that that's actually really unlikely. So because this is such a small probability, it's unlikely that it could have happened by chance, and that means that there is convincing evidence against the claim. So because this is a small probability, really having trouble writing on the iPad, sorry guys. We do have convincing evidence. against the claim. Okay, let's talk about this for a second. If you're a little bit confused, why? So what we're saying here is, if we actually did a sample of 1,012 people and we got 67% of them drink the milk, because this sampling distribution is normal and we can calculate the mean and the standard deviation, we can find some probabilities. The probability that I would just randomly by chance get a sample of 1,012 people who only 67% or less say that they drink the milk, the probability of that happening is 1.9%. If their claim is true, okay, the claim that 70% drink the milk. So since that is highly unlikely, 1.9% is less than 5%, that means that probably did not happen by chance, which means that the claim was wrong. Like the mean is not actually 70%. It's actually lower than that, probably. We have convincing evidence against the claim because it's unlikely that we would get a sample with that by chance. I did also put number 37 on here because it was related, so I'm going to scroll back up. What sample size would be required to reduce the standard deviation of the sampling distribution to 1/2 of the value that you found in 35B? Okay, so we'll think about standard deviation real quick. Here's the formula. Do you notice that I have to divide by n? It's kind of the key to this situation. So originally, I had, this was 70%, so then I had 30%, and then I had 1,112. If I want this number to be cut in half, maybe we should just think about this in terms of algebra for a sec. I want it to be this, half of this. I need to think about what is going to have to be with this n, like in order for that to happen. So the square root of 4 is 2. So notice that this blue, that would give me this, because the square root of 1/4 would be 1/2. So basically, if I want to cut my standard deviation in half, I have to quadruple my sample size. So I'm going to need to do 4 times n, so that's going to be 4 times 1,012, and that is 4048. You could like plug that number into the formula and make sure that that makes sense, but that's a pretty common thing. If they're like, ooh, I want to cut the standard deviation in half, because we're taking the square root of it, I actually have to multiply the sample size by 4, because the square root of 4 is 2. Last one, actually last two, they're both multiple choice, and they're related to each other. So they give us a setting up at the top. They ask a random sample of 750 Division I college athletes, do you believe performance-enhancing drugs are a problem in college sports? Suppose 30% of Division I athletes think that the drugs are a problem. So again, I'm going to like those numbers that I see in the problem, immediately I'm going to label them. So I have a sample size, which is lowercase n. I have a p, because that is what they believe that the population believes, which is 30% of the population. And then the next question is, which of the following are the mean and the standard deviation? Technically, we would need to check the 10% condition. So we can kind of assume, and honestly, because it's multiple choice, you don't even have to show this work, that, 10% of 7,500 is what would give me 750. And so let's assume there's more than 7,500 athletes out there, Division I athletes. Again, this is multiple choice. You didn't even have to do that, but I wanted to be accurate here. If we're using the standard deviation formula, we need to check the 10% condition. So 10% condition is met. The mean of p hat, this is really honestly just a straight up plug the numbers into the formula. So the mean is going to be 0.3. The standard deviation is going to be this guy. So we're going to get 0.3 times 0.7 over 750. And I get answer A, which obviously already had the mean there, but the standard deviation is 0.017. And that's where that comes from. Now let's use that to help us with number 45. The sampling distribution of p hat is approximately normal because, okay, so we didn't actually have to use this, it's just a separate question. Approximately normal. The only way I can prove something is approximately normal is if it meets the law of large counts. So I need you to like put that on a flashcard, put it in your memory somewhere. In order to determine if a sampling distribution of proportions is normal, you have to check the law of large counts. So this has to be true, and this has to be true. Which to me just pretty much straight up looks like B.